Welcome to Western Colorado University Chemistry Lab. Hi everybody, this is Gerald Ryder. I teach some labs and I also help write the labs, so we are making a few videos as we go to try to help you understand things a little better. So first of all, empirical formula. Empirical formula is just the smallest ratio of atoms in a complex set. I thought we'd just show you a few different examples. In the example in the text, we give you sugar. So glucose is a ring structure. And if you count these up, it has a formula of C6H12O6. And typically formulas like this, we don't really ever write an empirical formula. Sometimes you do if you make a new drug and you can do a elemental analysis and say, well, we know it has a formula of C, so the smallest ratio of this, if you divide everything, would be CH2O. So we could divide everything by 6, and you'd have that simple number of ratio of atoms. So you could do an elemental analysis on a new compound and say, well, we know the ratios, and then you could defer that it's probably what you thought it was. Another place you see it a lot is with polymers. Polyethylene is probably the most, I think it's the most produced chemical now in the world. It's plastic bottles, plastic grocery bags, that sort of thing. And this just keeps repeating for miles. Well, maybe not that long, but it's a huge molecule. So a lot of times they'll just say the empirical formula for this, and it's basically just going to be this part right here. So the empirical formula for that is just going to be CH2. Okay, another place you see it a lot is if you are doing geochemistry. So here's an example of a couple things similar to what we're making in lab. This is salt, sodium chloride. So there's one Na for every Cl. So these purple dots are symbolizing a sodium, and these Cl's would be chloride. And they just would, so if you look at this overall structure, it kind of would go on forever. And you don't want to say it's in 1 million Cl 1 million, you're going to do the lowest whole ratio. And here's this crystal salt, which is kind of cool because it makes a perfect little cube because this crystal is a cubic structure. And here's an example of magnesium chloride. So you understand magnesium has a charge of 2+. Chloride has a charge of -1, so you need 2 Cl's. And if you look at this structure overall, this would be the magnesium, these would be the chlorides. So if you add them all up, you're going to have 2 chlorides attached to every 1 magnesium overall. So in mineralogy, you would see structures like this a lot more. Truthfully, if you're doing organic molecules, which is carbon-based, with this sort of thing, no one ever writes the empirical formula. But there's lots of references, and it's first jumping into chemistry, so it's the first thing we do.